Okay, I think, is it about time? Must be about time. Yeah, 1 minute over. So we are late already. So welcome, and I hope you have a great event today. Not so many of you are here, but I try not to look at you because there's light shining into my eyes. And okay, I'm going to talk about Kotlin DSL today. I hope to make it under an hour. In fact, I figured it's only 50 minutes that I have, and then I have to make it under 50 minutes. Anyways, I will not change the title today, but it should have been, the title should have been probably something else, like yet another DSL talk. How many DSL talks you have seen so far in the past? Do you know anything about DSLs? Yeah, right? Like the whole room raises the hands. Of course, DSLs is not something new. There are a lot of materials on that. There are books on how to create DSLs and how they are different and so on. And normally, when you talk to people that I'm going to promote some kind of a DSL to you, people are really, annoyed. Why are you talking about this old thing again? Normally, people don't like DSLs because the DSLs have a bad connotation, because in the past, normally the DSLs could be used by the authors only. It was so hard to use. I think it's changing because tooling is getting better, much better. And, well, that is why we see a lot of DSL talks again, especially with Kotlin, because the language enables it better, and the tooling is also keeping up. So, let's do a little bit of introduction today, because it's a DSL talk. I should mention that there are two types of DSLs, right? There are external ones where you normally develop some kind of a grammar and tailor your new language, brand new language, to a special task, like, I don't know, and build files. Anyone remembers that thing? Yeah, so that's a DSL for building, right? Even though it's an XML, but it has like a special vocabulary. And internal DSLs, where you basically don't develop any grammar yourself. You don't really have to write a parser. The parser is there for you by the host language. And it's probably not even fair to call those kind of things DSLs, because it's not really a different language, it's just a different vocabulary, right, that you use to implement the syntax, adjust the syntax for a specific task. So that's a really nice idea, and especially if the language supports it so that it's easy to write and easy to maintain. And this is the topic we are going to talk about today. All right. So I will skim through many examples right now, not really explaining how they work and what they are, but I want you to notice one thing. I have like 7 examples or so. So here's one. This is the library to generate HTML, like by Kotlin. There's just this library. You add it to the project, and you can write this kind of code, and it will generate a valid HTML for you. Anyone have used it before? No? No one? Strange. Okay. By the way, are there any Kotlin developers who actually use Kotlin in production? About a dozen of you. Okay, good. So Anko is also another library that comes from Kotlin for building the layouts on Android. As you can see, there is like a layout. You can add elements with the properties and so on. And it is quite readable, right? You kind of look and understand what will be there. There will be a vertical layout with a couple of text fields and a button. Probably that's the first thing you notice. Another one, well, Gradle is pretty popular. If you didn't know that you can write build files in Kotlin now, well, now you know. Another example, Exposed library, also from JetBrains. That's the library for accessing the databases. As you can see, like there are some special keywords like transaction, create cities, meaning create a table. So it will generate SQL statements behind the curtains. Next one, Kotlin. Nicola say yes. He's the author. So I think it was a hobby project, right? So it was a hobby project, but it is very nice. And there is like an official one, Vaadin on Kotlin, right? Which looks mostly the same. It probably has just more mappings, right? I haven't looked at it, but it looks very similar. So, okay. There is also Kotlin DSL for generating Kubernetes configurations. Also very nice library. A former colleague of mine created it. There is Kotlin DSL in TeamCity. I work for JetBrains. I work with TeamCity developers, and we have our own DSL for configuring the builds inside TeamCity. And that is, well, that's in Kotlin. That is also pretty readable. There is like a VCS root, which means like there is a repository. If I would go and check the definition, it would be a Git repository with the URL and branches. And then I describe how to build the project. I give the task an ID. I say that you should monitor some repository artifacts, which artifacts should be published after the build, what are the steps to build the project, and so on, like how to trigger, configure the dependencies, and so on. So it's pretty flexible, and it's readable as well. And another one, again, Ktor. And this is an example that shows that actually there are two DSLs. The one from Ktor, like routing, get, those are the vocabularies that you get by Ktor. And if you look further, you will notice that HTML generation library in the end, right? So we start intermixing those different tasks in one code. And apparently we can mix the different DSLs. So why not? Okay, did you notice that they are very similar? Those all examples are very similar by the structure. They use different vocabulary, but the syntax, of course, it comes from the fact that the host language is Kotlin, but they have all similar kind of structure, nesting, right? You create one structure on the top, then you move further by defining like more elements inside the block. What I mean by that, let me just explain a little bit more. So we have one term, we open a lambda, we open another lambda inside the block, we assign some variables, we probably can assign a result of the lambda to some other field inside that block, and so on. And we might have like some additional options to tune this DSL depending on what you want to actually do, and maybe call some real code, right? So can be constructor call or a function call, because we are inside Kotlin. That's a valid Kotlin code right now, and obviously it gets the support from the IDE with all those auto-completions, syntax highlight, refactoring capabilities, and it feels really like magic when you do it. Okay, so let's write some code and see how it could be done. I have a really small example that is prepared by a colleague of mine, so credit goes to Evgeny Petrenko. He created it, I think it's just very small, but it's a really precise example that demonstrates how you can actually develop this kind of APIs on top of existing code. Okay, so I hope I can make it bigger, right? So here I have Java classes. I have a few builders. We go and open those, so they have getters and setters and fields that just create some kind of an object graph, object structure. And here's the example of the code that we write using those classes. So we create a builder, we set the values, and so on, right? And then we print it out. So this is a very, I would say, very readable code, right, in Java, right? Do you agree? right? Nodding. Everybody is nodding, right? Okay. So let's execute it. We start like doing changes in small steps and see where it gets us. So it prints that the client is created, and unfortunately this class doesn't have a toString method, then it just prints the name and the reference. And imagine now that those classes are somewhere packaged in a jar. They're in the library. We cannot change it. We don't have the control over those classes, and this is what we have to work with. And maybe we can, so we cannot modify those classes ourselves. Like we cannot change the source code. But we can build on top of those classes, add some syntactic sugar, and get a nicer program out of it. So let's make a first change that we want. So we actually want to pretty print this client, so that since we are in Kotlin, or we are not in Kotlin yet, we actually can copy this Java code, open a Kotlin file, and paste it. And if you have tried it before, the IDE will suggest that, hey, this is the Java code that you're pasting right now. Can I convert it for you to Kotlin? And I say, of course, please do that for me. And I will see some of the small changes already there. So what they are, first of all, we don't have to write a type. If we wanted to write a type, of course, it's possible, but we have type inference. Sorry, where is my interesting switch tab? Interesting, I haven't seen it before. Maybe it's the presentation mode or something. Okay, so thank you. So we don't have a type. If we wanted to write a type, we could do that, client builder, right? But we don't have to. Then we don't have a new keyword. For me personally, it was like when I saw that you don't have to write a new keyword, I was thinking like, why even it's important? And when I started to write program in Kotlin more and I had to switch back to Java, that was a major annoyance that I had to type the new keyword. I never even thought that it's important. And semicolons as well. Okay. Then instead of getters and setters, we suddenly have these assignments, which is actually due to the fact that we have properties in Kotlin, right? So instead of actually assigning the first name directly, it actually calls the setter. It's just the syntax on top of what we have. And so on, right? But we did not improve the application yet because it still prints client name, the class name, and the reference. We probably want to pretty print it. And we cannot change the host class, so we cannot change the Java source code. But in Kotlin, we have the ability to add extension methods. So it's like a utility method, right? In Java, we would have to write a new method, put it into the utility class, pass in the parameter, the object as a parameter, and then try to pretty print it. In Kotlin, we do it a little bit differently. So client dot, let's say, to console string, and then return a string, obviously. Forgot to write the type, string. And return, I'm a bad typist, as you can tell. Then we have, actually, since we are adding this method to the client class, this reference will actually be the client, right? So we don't actually have to print this. We can just use Twitter handle plus, let's say, a company name, right? And, well, there are some nice tricks that you can do in IntelliJ, say to, to move it to the template so that we don't have the string concatenation in the code like this. It's a little bit nicer sometimes. And then we can actually replace this part by calling the method client to console string and run it. There's some compilation. So we can see the pretty printed format from the new code that we just added. We didn't change the initial Java classes, we just get the new behavior like this. So one little thing that you can improve here is that we probably can change it so that we don't have to call the method instead, but access a field. So it would seem like we are accessing a field. And it means that we should add not a method, but a property, right? So the syntax is almost the same. Client, console, string, and it should be a string. And then we say that it should be this code. Why is it not compiling? Yes, thank you. Right, so we get a field like entity for the class, right? And instead of calling a method, we would call the string, and now it's just a matter of choice whether we want to move this concatenation into the string, so use a template, or just, do it the old way. I prefer it like this. Anyways, those are two small language features that kind of get us closer to all the abilities to write the DSL. So we can add new behavior to the existing classes without actually changing them, and that is really a nice thing. So if you remember the examples I have been showing to you, there is always some kind of a root method that we call to create something. And in here we are creating a client. So why don't we have a create method for a client? So fun, create client, client. And it returns a client, of course. Okay, but then we should be able to create it somehow from something, right? Or like if we just move the code inside this block, doesn't give us much. So what we actually want to do, let's type some code here and start changing it. Well, client equals create client. And if you remember those examples that I've been showing to you, we would have something like a nesting structure. But we will not start creating it right away. We are going to proceed through little steps and see how we get there. Right, so we first have a method. And, well, we probably don't need this guy yet, but let's keep it for now. It will not be compiling this time, but we will see at some point it will be fixed, right? So in Java 8, there was added a new interface that is called a consumer. We start, with something that is probably not so intuitive, but we'll see. So in Java 8, the consumer is one type argument expected for the interface. Yeah, so it needs a generic type. And the consumer interface, it represents, if you go and read, it represents an operation that accepts a single input argument and returns no result, right? So it basically would do something with that object, with that mutable object inside the code that we are passing in, and this way we are going to get our result. So the thing that we should pass in is this builder, because this is the thing that builds our client. All right, and inside the code, we can create, or should it be client actually? Okay, let's see. Builder equals client builder. Client builder. Yes, because we are going to give this consumer an instance of the builder, right? So it's the client builder, and then we can call accept on that interface and provide it a builder instance. And all we need now, after this call, the builder will create the client internally. And all we need to do, so all the values will be set already. And then we can just call builder build. No, builder build, right? So this is the factory for our clients. Now we are passing in the interface. So we need an implementation of that interface that will actually be instantiating all those fields that we have here. And in Kotlin, we can pass in something like a lambda, but before we get a lambda out of it, we will have some little steps in between. So object is the way to create an anonymous class here. Consumer with client builder. And okay, so it tells me to implement the method now, which is the accept, and we are going to move that in special code into the inside. And it doesn't compile right now because I have a wrong name of the parameter. And if we remove the redundant client from here, then we don't really need this one anymore as well. So we kind of introduced a layer of complexity, actually. We didn't make the code simpler right now. But it gets us, yeah, there is a question. There is no new keyword in Kotlin. This is the syntax in Kotlin to implement the anonymous classes. We will get rid of this right now. No worries. Yeah. So probably on the screen you cannot see it, but the IDE warns me that I can simplify this code a little bit. It tells me that I can convert to lambda. And actually, if I do that, it removes the object. And after that, it actually tells me that, hey, you don't really need this generic parameter. Let's remove this generic parameter. Now, it's simplified a little bit, but the original code, as you can see, it's still there. It's not getting any simpler for us right now, but we can do some little steps to simplify it again. So since we have just one parameter, we can actually rename it to it. That's the implicit name of the parameter inside lambda, if you have just one parameter in Kotlin. And since it is an implicit one, we can actually remove it altogether, right? So like in those small steps, we are improving our code, but the structure seems to be still the same. So we are still kind of not getting any benefits of our transformation here right now. Okay, but we can improve it on it a little bit. What if we, since Kotlin provides lambdas out of the box, why would we need to use that interface at all? We can actually define that we only need a lambda that does nothing, and just call this lambda inside the method. Just transform it a little bit. And in fact, then we don't really need this consumer interface anymore. And now again, IntelliJ suggests that we can improve it a little bit. So move the lambda, since it's a lambda, and in Kotlin you can, if it's the last parameter of a method, you can move it out from the braces. So we can remove the braces and just have create client, open the braces and open the block and have it simplified again, right? So it already is taking shape. Remember those examples, right? So we have just one block and we are moving towards nesting now. One thing that bothers me here is that you have to repeat it all the time. Now see, it is the implicit variable with type of client builder. So all those dot first name, dot last name should be called in the context of client builder. in Kotlin, there is a very nice feature that is called lambda with receiver. So it's like an extension method that we have seen before, but it's a lambda, and we can say that it belongs to a type. And the type is currently the client builder. So that's the syntax, right? So we take the type, put a dot there, and say that this lambda is now an extension on that type. So this way, this reference is actually the client builder, not it anymore. And since we don't have to write this explicitly anymore, so calling the first name directly will actually reference the first name in the client builder. So whatever is written inside that block is happening within the context of client builder. So we simplify it again. Now you see the pattern, right? So we might introduce new builders like this to create nesting. So what we need here is to add a couple of new methods. What I actually want to do is to have something like this. Twitter handle equals the value, right? Instead, this all code. And that could be done just with one line of code. What we need here, we need to be able to call the new method that we are adding in the context of client builder. So obviously it will be then an extension function called Twitter that should take some parameter. Right? So it already compiles. We just have to be able to assign this value to the builder that we should actually create. So for that, we need to create a scope, like the same way as we did for the client builder, right? So, but it should be a different type. And we have a Twitter builder in there in our application, Twitter builder dot and return, unit. And in here we can assign the field that we need through the Twitter builder. Now we have to somehow pass in this the block into the context, because currently we only have like a build, right? But we need to execute this assignment somehow. And in Kotlin there is a special function called apply. So I pass in this block, the code block that I'm using as a parameter. I'm passing it in to the apply method, and it will execute, in the context of client builder. It's also an extension function, but it applies to any type. So it's an inline function from the library that applies to any type and executes the block within the scope of the type. Okay. And basically we have this code already compiling, right? So we have a Twitter builder. Within the scope of Twitter builder, we are assigning to handle, and we can do the same for the company. Okay, let's do the same. Client builder, we are going to add a new extension method called company. It should be the company builder, of course. Company builder. And we use company builder inside the method as well. And we assign to a company, of course. So we now can just, remove this guy, open the block, copy this stuff, and remove the redundancy. Okay. Good. And it's compiling, right? And it works. So let's check. Run. Works the same way, right? So we started with this, and we got this, right? I'm not saying that the previous code in Java was really bad, but it's a small example, but you actually have to parse with the eyes and really understand what it is doing, while on the right, we have a nesting structure, which is really easy to follow with eyes and understand what you're actually creating. Now, what is the benefit of this transformation? If you are just adding this kind of fancy functions into your application to write this kind of code once, you are not probably getting any benefit. You are just introducing new complexity to the application for your colleagues to maintain, right? They might be happy, but they might not be happy. The actual benefit you get is from extracting those new functions into a library so that you can reuse it. So the actual benefit you get from this kind of approach is when you have to write this kind of structures over and over again. This is, I think, the greatest benefit that this approach provides. And as you see, we didn't really create a new grammar. We didn't really introduce any parsers, of course. And if we had to mix it with some kind of other library that provides a new way, like some other way to write structures for something else, we can combine them, right? So every task gets its own DSL, which is maybe a nice thing. Okay, so, but one problem still exists with this code. Let's see. If I move this company, so we have like two separate structures, Twitter structure within the client and then company. And what if I do a mistake and do it like this? You see the code still compiles, and that is really strange. You should not be able to call company within the Twitter block. So in Kotlin 1.1, there is a special marker annotation introduced to handle this kind of things. The marker annotation works in a way that you should mark the receivers of the calls, meaning you should annotate the classes to which those new methods belong, so that the compiler will check so that the new method should be called on a correct receiver. In our case here, we cannot annotate the Twitter builder and company builder because of those limitations that I set in the beginning. So we actually can do the following. Let's introduce this marker annotation, say the client DSL, and DSL marker is this original annotation that you have to use from the Kotlin standard library. And now we can actually do the following. Introduce the new class and call it client builder DSL. That extends the client. Yep, I will fix it now. Thank you. Wait, what? Okay. I don't need to override anything, so one line is enough. And then I mark this class with this new client annotation. And I should do the same for the other two. So it will be Twitter builder, and obviously company builder. Okay. So, and in my code that I have just written, I have to obviously exchange the receivers a little bit. So it will be client builder. Then there should be a DSL, and here should be DSL as well. So everywhere I change to the new classes. DSL. All right. So Still the same code, slightly different classes, introduced one layer of annotated classes instead. And now if I go up and try to do the same trick again, it won't compile anymore. The compiler will say that the unit that I'm currently calling cannot be called in the context of an implicit receiver. Basically meaning that, hey, you are not allowed to call company within the context of Twitter builder. That's a really nice feature, I think. And this way we can actually make our DSL safer, especially when we proceed building more complicated examples. All right, that's one example that I wanted to show. I still have time. Do you have any questions yet? Yes, I don't want to look at you, but... Yes?
One possible mistake here would be to specify the company name and city twice. Is there a syntactic way to prevent that?
Very good question. I don't know the answer. We can experiment and see what we can do, but no, I don't know. Even in the next example, I have this thing, and yeah, I don't know how to resolve that. The other example I wanted to show is basically the same. All the ideas are the same, but it demonstrates another language feature that I want to show. This. Okay, so here I have basically the same idea, right? I have some nesting. The syntax, some kind of field like equals some value in those braces is called in Kotlin named parameters. So I can just amend that, and I don't have to type it. IntelliJ will show me the hint what it actually is if I turn it on. But sometimes you might prefer to be explicit and type out the parameter name. Because if you open the code in some text editor that doesn't support auto-completions for Kotlin, then you would immediately see what it actually is, right? Okay, that is not really the point. And getting this nesting structures is also not the point currently of this example. The point is those two lines, right? Let's see. So in the beginning, like to assign the date time, I'm using this Java type, like Java standard library, local date time of something, right? We can even make it more unreadable by removing the month name from here, and I have to type 11 instead. Who would have thought that you have to type 11 instead of 12? Okay, that is why we have those enums, actually. But anyways, I thought that what would be if I create something that would be more readable for this kind of use case? It was just a small exercise. So if I want to type 11, right, it means, and call some sort of method on it. So I'm calling actually December on 11. It means I have to extend int type with my new method, right? So let's see. I create a function that is an infix function. The infix function allows me to skip the dot, and if I have just one parameter name, one parameter for that method, then I can just write it like receiver, skip the dot, method name, and pass in the parameter. So this is the structure that I'm currently calling, and it is enabled by adding December extension method to the integer and defining it as a infix method. So from there I get local date because I'm passing in just, I have only the year and the day, right? So I only can use local date. From there, I can add an extension method to the local date, because I would like to use this at method. So on December 11th, 2018 at some time, right? I didn't have to figure out how to make it without the braces. It didn't work for me, but I thought, what if I use a pair, what if I use a pair type in Kotlin? I could have just written like 11 to 0, so I get a pair of two values, and use those two values to initialize time in my local date time object. So, but the operator precedence is the challenge here, so I have to type it inside the braces. And the add method would take then the pair as a parameter and call it on the local date and return local date time instead. So I can use inside that method could set the hours and minutes for that date and get local date time that way. So the point of this example is having infix functions as well to write this kind of nice syntax. Okay. We still have 8 minutes, but I would like to actually stop here, and maybe if you have some questions, answer them. But before that, if you are new to Kotlin and you would like to learn it, there is a very nice new book called Atomic Kotlin, written by my colleague Svetlana Isakova and Bruce Heckel. And we also started a new course at Coursera. So if you want to learn online, there's the course for you. Obviously, there is Kotlin in Action, also a very great book. Also, Svetlana wrote it with the other colleague of mine, Dmitry Jemerov. And yeah, if you have any questions afterwards, I'm available on Twitter. You can send me the feedback. And just follow me for whatever reason. Okay. So I'm open to any questions, and if I don't receive them now, we have a booth. There is a JetBrains booth in the hall, so I will be there, and you can come there. Yes, Nicola.
Yeah, thanks for the talk. It's not a question, but I think regarding the fact that you can call the same method twice, I think that with the new version 1.3, you can check with contracts.
Yes, there is a new feature, the experimental new feature in Kotlin called contracts, and maybe you can apply that by checking that the value you're assigning to should be null, or yeah. If it's not null, then you cannot assign and break it. Okay, so if you can check it, then it would be great. I haven't looked into contracts yet. It's a very new feature, but maybe that's applicable. Right, there is another question.
Hi, I'm totally new to Kotlin, and I see it's surprising, and basically I've only seen the first working example right now, and it makes me ask a question. As Java is strictly declarative language, and basically if you are new into Java, what you need to know is grammar, like in any other language, and words. So if you learn this stuff, you can basically start writing Java. In a Kotlin, as I've seen, there's kind of a lot of magic behind hidden features that you need to know except language and grammar. Like something is it and typecasting and so on. What is the benefit?
The benefit is that, well, the biggest benefit by the comments of my colleagues who actually are developing Kotlin itself is that there is a research that confirms that the less code you write, the less mistakes you make, right? So the programs are more readable. Just the statistics would play like for you that you may make less mistakes. Okay, there are some magical things. There are new concepts that are really just introduced in Kotlin. They're not in other languages, but they are very easy to grasp. If you're a Java developer and you're moving to Kotlin, actually, it is possible to start writing Kotlin in a Java way without those new fancy features, and as you progress, start changing your style into more idiomatic Kotlin style.
Yeah, but still, when we get a new colleague who is absolutely not familiar with Kotlin, it's a lot of work to do to incorporate him into our code if he has no experience.
Oh, it's always like that. With the new things, you have to be trained. Yes.
Okay. Thanks.
It's not magic. There will be no magic that you take a new thing and you can be productive right away. But the guys are really working on, the features to make them coherent and understandable and intuitive to be, like, for the developers to be productive as soon as possible. Yeah.
Oh, I have one question.
Yes.
You wrote the Java code in the Kotlin one, and what's the proof that you rewrote that exactly the same? I mean, that it still does the same thing.
Unit tests? Of course, I didn't write a unit test.
Okay.
But
Thanks.
I mean, okay, from the practical point of view, why would you just go and start rewriting your application in Kotlin? If it works, if the code is readable enough for you as a Java developer, there is no good reason to go and just to start rewriting. There should be something else in it, right? If you write new code in that application, you start gradually migrating. The very critical part of it is that Kotlin is able to integrate with Java seamlessly. And you should be able to call Kotlin from Java and Java from Kotlin in the same way. And that is possible. This is what Kotlin is working very hard on. And it works. Yeah, more questions? No? Oh, there's a question.
Hello. I'd like you to explain why the Kotlin needed the special annotation in the example to make sure that you're not calling it on a wrong receiver. I'm actually quite impressed by the type inference in Kotlin, and I'm confused that it didn't know it right away.
Well, it probably goes beyond type inference, right? So you should be able to... Maybe I can switch back to the code and try to explain. So here, this is the example, right? So we moved in. If my intention is to only kind of limit this example to be able to call only the methods that are available in that context, right? Then in practice, it's limiting too much. What I mean is that you might have a function that, let's say, fun blah, that returns a string and something, right? And I want to use that function to initialize this field. I should be able to do that. And if I only limit to be able to call the methods that are available to this receiver, then I'm limiting too much. I don't get enough flexibility to be able to initialize those structures inside. And it's a very common use case that you actually need to call some sort of a function to initialize this field.
Okay, thank you.
This is probably the simplest explanation I could think of. All right, I think we are out of time in 38 seconds. Thank you for coming. I hope you have a great event. If you have more questions for me, find me at JetBrains booth in the hall. And yeah, thank you. Have a great conference.